Today, we do some myth busting about the fifth generation networks, 5G. Are you afraid yet? Are you concerned yet? Let's have a deeper look. I hope this video lesson removes the clouds and brings in some light to your mind. To me, bringing in 5G unnecessarily and perhaps prematurely when the 4th gen networks are doing pretty fine by themselves seems a bit overboard. If it ain't broke, I'll fix it till it is. So I can look busy while actually fixing the darn thing later, said our dear Professor Whodunit. 5G networks are digital cellular networks in which the service area covered by providers is divided into small geographical area called cells. Analog signals representing sounds and images are digitized into telephone, converted by an analog to digital converter and transmitted as a stream of bits. All the 5G wireless devices in a cell communicate by radio waves with a local antenna array and low-power automated transceiver in the cell over frequency channels assigned by the transceiver from a pool of frequencies that are reused in other cells. The local antennas are connected with the telephone network and the internet by a high-speed, high-bandwidth optical fiber or wireless backhaul connection. As in the other cell networks, a mobile device crossing from one cell to another is automatically handed off seamlessly to the new cell. Some service providers are using millimeter waves. Millimeter waves have shorter range than microwaves, therefore the cells are limited to smaller size. Millimeter waves also have more trouble passing through building walls. Millimeter wave antennas are smaller than large antennas used in previous cellular networks. They are only a few inches, several centimeters long. Another technique used for increasing the data rate is massive MIMO, multiple input, multiple output. Each cell will have multiple antennas communicating with the wireless device, received by multiple antennas in the device. The multiple bit streams of data will be transmitted simultaneously in parallel. In a technique called beamforming, the base station computer will continuously calculate the best route for radio waves to reach wireless device and will organize multiple antennas to work together as phased array to create beams of millimeter waves to reach the device. Over 20 networks are deployed using mid-band spectrum from 2.4 to 4.2 GHz. Mid-band networks have better reach, bringing the cost closer to the cost of 4G. The Universal Mobile Telecommunication Systems, created and revised by 3GPP. The family is a full revision from the GSM in terms of encoding methods and hardware, although some GSM sites can be retrofitted to broadcast in the UMTS/WCDMA format. Some companies are announcing low-band 5G in December of 2019. The performance, reach and costs will be similar to 4G in the same band when 5G systems are fully developed and can access more carrier frequencies. The new 5G wireless devices also have 4G LTE compatibility, as the new networks use 4G for initially establishing the connection with the cell, as well as the locations where 5G access is not available. 5G can support up to a million devices per square kilometer, whereas 4G can only support about 100,000 devices per square kilometer. 5G speeds will range from 50 megabit per second to over 2 gigabit per second at the start and expected to grow to even 100 gigabit per second, 100 times faster than 4G. The fastest 5G, known as millimeter wave, delivers speeds of up to and over 2 gigabits per second. As of July 3, 2019, millimeter wave had a top speed of 1.8 gigabit per second, much faster than 4G's highest average speed of 85.8 megabit per second in Chicago. The problem with this, though, is that it cannot go through walls, trees, etc. because of the high frequency. Sub-6 GHz 5G, mid-band 5G, by far the most common, will usually deliver between 100 and 400 megabit per second, but will have a much farther reach than millimeter wave, not being limited by walls, trees, or other obstacles which interfere with millimeter wave transmission. Low-band spectrum offers the farthest area coverage but is slower than others, though it is still faster than 4G. 5G NR or 5G New Radio speed is sub-6 GHz band can be slightly higher than 4G with a similar amount of spectrum and antennas, although some 3GPP 5G networks will be slower than some advanced 4G networks, such as LTE/LAA networks, which achieve 500 plus megabit per second in Manhattan and Chicago.
It is time that we bring our learning to a close today. I know many of you, my friends, are now worried about your health and some other related issues concerning the fifth generation networks, especially since you have heard that millimeter waves may be used. Now, I'd like to tell you that the only threat is from high energy density millimeter waves. You see, most of the 5G that we will be getting far from cities is mostly like 4G networks. Others are mostly similar to Wi-Fi, only at very specialized locations could we get the real millimeter wave 5G, and I do not think such technology will be readily available in this current decade. So you see, there's nothing to worry about. So now that I have filled your head with jargon, I hope you all the best. I hope you learned something today of value, and I hope you can pass it on to your other friends. Thank you and goodbye.